Okay, this is the video segment for repeating chapter 14 where two planes of symmetry are used. In the earlier segment, I clamped the two ends of the bottom pin and pushed the two ends of the top pin up by some amount. I would like to repeat the same problem, but using the two planes of symmetry that exist, namely YZ plane and XZ plane. The first thing we need to do is to go and cut this into pieces. So we are in assembly design right now. Let me go find the saw somewhere. There must be a saw somewhere here. If not, we have to get it. Let me see. I think I have probably closed that particular toolbar which has the saw in it because I never used it in the previous videos. So what are we going to reset these things? So where is that? Tools, customize, because I don't remember the name of that toolbar. Customize. Okay, just give it a second. If you don't remember the name of the toolbar, you just have to reset the entire thing. The saw in the assembly design acts differently from the saw in the part design, and differently from the saw in the wireframe and surface design. Okay, so let's just give it a second right there. So we go toolbars, restore all contents, restore positions. We say okay. I close that. Let me see. I don't need this. Let's pull these out. Some of these toolbars I don't need it, and if I don't need it, to make sure that the screen is not cluttered, I can close them. None of these I need. None of them have the. Oh, there it is. There's a saw. Okay, you split it and read the bottom, the prompt areas carefully. The prompt bottom left corner, it says select a plane, face or surface of an existing split. So I want to split it with that vertical plane XZ. And what it's telling you is that if you use XZ, all of these are affected. Which ones do you actually want them to be affected, and which ones you don't want? Obviously, all of them I want to be affected. I want this thing to be affected, and this thing to be affected, and so is that one. And it doesn't matter which side you pick. So I flip the arrow so that I keep the other side. No particular reason. There. Okay. And then I cut it with this plane, which is the XY plane. So once again, split XY plane this time. Everything that you want to be affected, I can do it all at the same time, and it doesn't matter which side you pick. So I keep this side. Actually, let me flip it and keep the other one. Not really, doesn't matter. Okay, good. So these are the planes of symmetry. Let's go and mesh it. We go to start. You know what? Why don't we save it first? Save. We now go to generative structure analysis. What I did in the previous tutorial, I made the elements around this hole smaller, and I showed you how to do that, so I'm not going to bother with it. Okay, you go ahead and do it if you want. Check your first video or look at the stuff that you did 2-3 weeks ago and find out how we actually refined it in a certain area, because you're responsible for that on the final exam. Alright, so let's actually use the what is clamp. It's this is clamp. This face, bottom face, is clamped. The face of the pin is clamped. Okay. Every other surface that we have created is surface slider. So let's start patiently. That's this piece. The face, half face of the pin, right there. See? Right there. The half face of the bottom pin, right there. Okay. Face of the pin. This face of the block, that face of the block, that face of the pin, and that face of the block. And that's pretty much it as far as symmetry goes. Now we push this thing up, and remember how we did it? We selected pushing in the Z direction, that face in the direction Z. Okay, and then we can go change it. Where's the change? Oh yeah, enforce displacement right there, and you select this, and the amount is 0.01 in the upward direction. Very good. And do not forget, on purpose, I'm going to try pretend that you know, I'm all okay and run it, but you will see. Let's do it. There's something else we have to do in case you haven't realized that. There, it didn't run, and let's see why. Because the pin and the block do not see each other. That's because we have to create connection between them, and as in the previous problem, I make the connection a contact connection. So cut this. Okay, let me see now. Deactivate this last plot. Good. So let's go and create two connections. This is the top one. So a connection between the surface of the top pin, and let me hide this. For the second connection, right there, second connection, the surface of the hole, the entire surface of the hole. And if you want, I can call this thing top connection. It's easy to remember, there's only two connections, but if you have 50 of them, you want to know what is what. And then same thing with the bottom one. The order is not important what you pick, whether you pick the pin first or hole next. Right there. Oh, did I rename it? I can't remember. Wait, let me check this. No, I didn't rename it. So I'll call this thing bottom. Bottom connection. Okay, good. And we're going to make this thing contact. You can make it fasten. You're going to lose marks. That's all. As long as you're okay with that, it's fine with me. So contact with this. Do not fool around with clearance, friction, and no sliding. Okay, excellent. Well, I can bring these, if it makes you feel better, I can bring these in the front. Now, when we did this thing last time, a whole bunch of things happened. There were lateral movement of the top pin, the lateral movement of the block, the lateral movement in the direction Y of the pin and the block. Now, these things will not happen when we use symmetry because of the surface slider constraints that we have. Okay. In fact, using surface slider makes you get to a final answer quite faster. Don't worry about warning. Run it, and you can see that it's going to look good. Now, I'm not disputing. I'm not discussing the quality of the numbers, but it's running. It did run, no problem. This is exactly the way it should be. Okay, except that the previous run, without any symmetry, I made the elements around the hole much finer, so probably they're more reliable. And you can look at the stress distribution. Let's see now. Material shading. Anything that you don't like, that's bothering you, you can hide it. So, for example, hide. Let's see, hide. Properties, hide. Restraints, hide. You see, it cleans up the screen. Hide. These are not deleted, they're hidden. And you can see better what's going on. What was that? Hide. There. Okay. All right. So this is with two planes of symmetry. What I would like to do now is pretend the top is pulled up, the bottom is pulled down by the same amount. So in that case, there will also be a plane of symmetry X, Y. Okay, so this is not the same problem as we are doing now, but it's a different problem. Now, before I do that, I want to remind you how to calculate the force needed to create that deformation. So remember, first we deactivate this plot. And when it comes to calculating the force, you go to sensor, create resultant sensor, reaction sensor. Okay? And the thing that I would like to find is this restraint, which is pushing it up, right? This one. Pulling it up. And then you say update sensor. Okay. When you take this number, 3,900 pounds. Okay? 3,900 pounds. In order to find the total load needed to achieve this deformation, you have to multiply this thing by 2. So the answer to this problem, you have to multiply it by 4. Because this is that quarter of the model. There is also the one adjacent to it, so that doubles it. There is also one on the other side, so that thing is multiplied by 4. Now, it is a big force, but remember, this is a piece of steel which is 1 inch thick, 10 inch high. It is a very, let me put it this way, thick piece of object, and you're displaying it by I think 0.01 inch, okay, 0.01 inch, which is almost 1 millimeter, so that requires a lot of force. Now the other thing is that, of course, I don't like it because that looks to be too large. You have to multiply it by 4, but that looks to be too large because I have absolutely no confidence in these numbers. Remember, I took a horrible mesh, did not even refine it. I took linear mesh without any mesh. So if these answers, if the mesh was acceptable, then the answer would be total load to do this thing would be 4 times this number, and that's what you write your exam paper. Now, don't cancel this, because if you cancel it, there's no way for us to know where you got this number. Say OK, and when you save it, this information is going to be saved so that we can check and find out where you got your number from. Alright folks, so we will go and repeat the same problem. Not the same problem, almost the same problem. Top pin moves up, bottom pin moves down by the same amount. Now, just to remind you, first of all, let me save this. Cancel. File, save management. This is the analysis we have to save. I never did that in that folder with 2 planes of symmetry. But I don't want to mess up my present problem, so what I would like to do, take the part and the product, the 3 parts and the product, and put it in a different folder without any links, because I'm going to cut this thing one more time. So I'm going to say tools, not tools, file, save management, take the product, which is right there, save as, in a different folder, go up on the desktop, new folder, and I say almost Chapter 14, 3 planes of symmetry, 3 planes, 3 symmetry planes, 3 symmetry planes. Okay, and I say propagate directory so that it also puts the parts in there, and there's total disconnect between the parts and the product in the earlier folder. So let me delete these things, and let me go to the folder that I just created. It was called almost something, almost Chapter 14, right there. And if I open the product, it's going to be this, and now I can cut it without affecting the earlier problem. So I'm going to